The Agenda in the Summer with Nam Kiwanuka is made possible through generous philanthropic contributions from viewers like you. Thank you for supporting TVO's journalism.
The Big Dipper, the Seven Sisters, Saturn, and Mars. Wonders in the summer night sky are eternal. All week we'll find out what's out there with astronomer Bryan Gaensler, astrophysicist Nathalie Ouellette, aerospace engineer Walter Stoddard, and physics and astronomy professor Matthew Johnson. Tonight, our solar system. That's next on the Agenda in the Summer.
One thing that I've been thinking about lately is that during the day, you know how you get caught up in all the to-do things, like all the things you need to do, the things you need to do in a day, in a week, in a year. And then there's times, again, maybe it's because I am getting older, I'm like, does this really matter in the context of things? Because when I think about like us on Earth, how small, how not insignificant, but like, I guess insignificant we are. The question that comes to mind is like, how big is our solar system? Walter?
Oh, that's a good question. And how do we measure it? And where do we stop counting? If you look at go all the way to Pluto, but then you have the Kepler belt that continues after that. So how far do you count? And we're discovering new objects all the time. And then what about the comets that are on the huge loops? Do we count those too? Because they are orbiting the sun, so technically they're part of our system too, even though we don't see them for 100 years or so.
So we don't really know how big it is. Is that the answer?
We have a ballpark idea, but it is very hard to define. There's no like sign and then you cross this line here and you're,
this way
you're
to
no
the solar
longer, that's right, exactly.
Space.
I think there's a sign, but it keeps moving. Like
that's right.
Where the solar wind stops,
yeah,
it moves in and out. Over that 11-year cycle that the sun goes through.
Yeah, so it gets the solar system sort of breathing along with the sun. So even that boundary is kind of changing. But we've sent probes, Voyager 1 and 2, and for like 10 years, every week we go, okay, now it's out of the solar system. Okay, no, now it's out of the solar system. And they have crossed a threshold where their measurements show that it is a little bit different. It seems to be a little bit less under the influence of the sun and more in what we call interstellar space. But yeah, this is nature, right? It doesn't have defined boundaries or lines or categories, and we're just trying to put our own definitions on it.
Brian?
Yeah, so I when I was early in my career, I worked at MIT where they were monitoring the data from Voyager, and it was like a running joke, like, oh, have you left the solar system again this week? And, they sort of rolled their eyes, but it just sort of illustrated just how complex the solar system is. And so sometimes Voyager would cross the boundary out into space, but then sometimes the edge, that boundary would expand and overtake Voyager from behind. And they were seeing these data come in just a few hours after they were received. And it was pretty exciting to talk to my colleagues and them actually talking over lunch saying something's happening, and if this signal keeps going up or dropping down tomorrow, I think we can say that we've moved into a new zone. So it's amazing that these satellites that were launched in the 70s with really basic technology and less computing power than a phone are still telling us now in 2023 what the solar system looks like.
That is incredible. But we do know that we have 8 planets, 5 dwarf planets.
Some people would fight you about that 8 planets.
Okay.
Some Pluto warriors would
right. Okay, maybe. Okay, I'll add that. More than 200 moons and more than 1 million asteroids within our solar system. How do we know if we have more planets in our solar system?
So we actually have a theoretical planet called Planet 9 or Planet X, which we think might exist beyond even the orbit of Pluto. We haven't observed it, but we've sort of seen all of the orbits of all of these other objects sort of accumulating into this one spot, aligning in such a way that leads us to believe that something is there gravitationally tugging on these other bodies. And so we think it might be something that's sort of the size of a mini Neptune, a little bit smaller than Neptune. But we've yet to observe it because it's so far away, it would be very hard. We have to wait for it to get a little bit closer to the sun. And you might say, well, that sounds completely ridiculous, but that's actually how Neptune was first discovered. It was theoretically discovered before it was observed because scientists at the time saw weird discrepancies in the orbit of Uranus. And so they're like, we think there's something there. And then a few years later, they actually observed it. So there's still a lot of discovering left to do in the solar system.
What is your favorite planet in our solar system other than Earth?
Venus. It's so extreme. It's the hottest planet in the solar system. Its atmosphere is like sulfuric acid, corrosive, and it's the planet of extremes.
That's why you like it?
That's a cool planet.
Yeah.
Yeah.
What about you, Walter?
I was going to say Earth because that's where I keep all my stuff. But if I need to choose a different one, then Mercury.
Why?
It's fast.
Yeah.
It's the closest to the sun. It's the fastest orbit. Messenger of the gods.
Oh.
Always on time. And I have a problem with being on time. So Mercury would be my favorite.
It's aspirational.
Yeah, you aspire to be like
I
Mercury.
aspire to be like it. Yeah. Keep
what
your
about you,
dreams in
Bryan?
front of you.
So I'm going to break the rules and say Pluto, even though Pluto got kicked out of the planet.
Can you tell us why
Brotherhood.
Pluto was kicked out? Just for
Well, this could get violent and complicated, but people were trying to define, in the early 2000s, astronomers wanted to actually write down a definition of what a planet was. And they said it needs to be round, it needs to orbit the sun, and it needs to be significant enough that it clears out its neighborhood with its gravity. And it basically, it's the only car in its lane. And so Pluto is round, and it orbits the sun, but it's not big enough to clear out its neighborhood. And so that meant that Pluto was kicked out. And one of the reasons I did this was sort of a practical one, is that if Pluto is a planet, there's several other objects that then are as big as Pluto and should also be planets. And people were saying, well, where is it going to be? What are school children going to do when you have to memorize 80 planets? So,
what about the children? When someone think of the children?
Exactly. Like, the line stops here.
Yeah.
So I was like, yes, death to Pluto, good riddance, you suck. Like, good. I'm so happy you're gone. And so I was a Pluto hater until those images came back a few years ago from the Pluto. Was it called Pluto Express? Was that
New Horizons?
Oh, New Horizons. Sorry, New
Horizons.
Horizons. And they sent back the pictures of Pluto, and I went from like a hater to a lover overnight.
It's got a heart on it.
Because it's got a little
and
heart. It's so
everything.
cute.
Yeah.
And it just made me realize that Pluto is like this. It's the odd one out. Like our standard textbook cartoon theories of how the solar system formed don't explain Pluto, and it's just this whole treasure box of things that we smug astronomers had not properly incorporated into our ideas. So I now see Pluto, like others have always seen it, as like, the little world that could. And so I've switched over, and I'm sorry, Pluto, for all of that.
Do you all
anger.
agree that Pluto should be the ninth?
I mean, is that what you're saying?
No,
you're
I
not.
do not think Pluto should be a planet, but it is my favorite world. in
It's
the
your
solar system.
favorite.
All
Okay.
right. All
We're
right.
not exactly the panel to make that decision.
What about you, Nathalie?
Since Bryan flagrantly broke the rules, I will also break the rules, and I will choose a moon instead of a planet, but not our moon, Enceladus. One of Saturn's moons. And if I had to bet on where alien life might exist in the solar system, I would not bet it on Mars. I would bet it on a world like Enceladus.
How come?
Because it's an ice moon, covered in ice, and there's a liquid ocean, we believe, underneath that crust of ice.
That's so cool.
And one of the reasons why we think there is that liquid ocean is because there are ice volcanoes on the top that is blowing out this water. And we've actually had some probes that have sort of like sniffed that gas and the ejection. And so there are these hints that we haven't found like life, but we found what could be food for life potentially in there. And so these water worlds or ice worlds, I think, are really interesting candidates in terms of finding alien life.
Well, what about Mars? You said not our moon, but let's talk about Mars. Is there a possibility of like life there on Mars?
I think there's a possibility. It's a really, I mean, I don't think there are like walking, talking Martians, but if there are little bacteria or viruses or something very small and simple on Mars, it's really, really hard to tell whether that's true without sort of going there and doing sophisticated experiments. And the probes that we're now sending or paying to send are getting more and more sophisticated and doing more experiments. My own gut feeling, and I don't work on Mars, is that very possibly used to be life on Mars, but that we're sort of looking now at a dead planet that sort of has lost a lot of its atmosphere and all the conditions for life. But maybe there's still something left behind from sort of a better time on Mars long ago.
And Natalie, when you said that there's a possibility of life on the moon of Saturn, I thought that was interesting because I think a lot of us think that life would be on the planets, but not necessarily on the moons.
Yeah, so moons are actually a great option because we were talking about sort of this Goldilocks zone the last time, but there are ways around this a little bit. Like, you don't necessarily need a magnetic field to shield you from radiation because ice can sort of do some of that. And so maybe the ocean world inside is protected a little bit, or even some of the worlds that are around Jupiter, you'd think they would all be too cold because they're very far from the sun. But because of the gravitational pull of something so big as Jupiter, it's kind of warping the planet. It's causing internal heating in some of these moons. And so, yeah, some of these moons are actually super interesting candidates, more so than the planets, I think, for alien life.
Of course, every Star Wars fan knows that the Ewoks lived on
That's
the moon.
right, that's right.
Right.
Andor, great moon.
Walter, I saw you nodding.
Well, and so Jupiter kind of stirs up a question for me, because you're talking about Pluto not being a planet, right? That it can, because it can't clear its orbit. Now, does clear its orbit, I thought Jupiter has some hitchhiker asteroids that are following it around, or am I mistaken?
No, the Trojans, which are like in fixed places on its orbits.
Right.
It's sort of like it's shepherding them around, actually, because it's so big.
Okay.
Yeah.
Okay, so that's okay then.
By the arbitrary definitions that we've decided.
It's so
yes.
big, yeah.
If you kick Jupiter out, like, no one would take us seriously.
Yeah.
No, of course not. Of course not. Though we could vote, I guess.
Yeah.
Okay. Well, gas planets like Jupiter and Saturn are quite large. Why wouldn't they pull smaller planets into their own orbit? Matthew? Okay.
Well, they're far enough away, and in a way they have. I mean, they have many, many, many moons. And so by the definitions we've been speaking about, we don't call them planets, but they can be quite big. Like Ganymede is the biggest moon in the solar system. It's probably as big as Mercury, if my memory serves me correct. So it's a bit situational, and it's like semantics, right? It's still a big chunk of rock. It's not a planet.
But you know, when the solar system first formed, the solar system was like a pinball game where you've got like the extra bonus level with, you know, a million balls going. So there were all these planets crashing to other planets. You know, we talked last time about that's where the moon came from. So there's probably a whole heap of planets sitting at the bottom of Jupiter and Saturn that just got sucked in early on. And it took a really long time for that to sort of settle down.
Yeah.
But the solar system's been relatively stable for a long time. All of the low-hanging fruit was picked off.
And it's
billions of years
ruled
ago.
by the sun. Yeah, the sun is so much more massive. But maybe you can talk about exoplanets where the star is not as massive as the planets, right?
Sometimes you'll have planets and stars in exoplanetary systems where the star is a lot smaller than the sun, and you'll have these gas giant planets that are 10 times the mass of Jupiter, and then they'll be sort of comparable. And then you get into this like really sticky situation where we have brown dwarfs, which are like super big planets who sort of are like stars and have part-way nuclear fusion at their very start, but they're not massive enough to sort of keep that going for their entire life. So,
What's nuclear fusion?
Nuclear fusion. So this is what the fuels the heart of our sun. Essentially, the sun is massive enough that at its very core, its center, it's able to crush down hydrogen atoms, and it pushes them together, and that's fusing the atoms together, which creates lots of energy. And we want to actually do that as well. That's a cleaner type of nuclear energy than nuclear fission, which we do. We break apart really heavy elements like uranium or plutonium. And so this is how stars stay alive, and they create that heat by fusing these atoms together.
Well, what keeps all the planets seemingly in orbit?
So it's all through the gravitational pull of the sun. Yeah. So you can sort of like imagine the solar system being this big rubber sheet, and at the very center you have like a bowling ball. That's the sun. And so all the planets are close enough to that big divot caused in the rubber sheet by the bowling ball that they're sort of trapped You might have like some demos of this at the Ontario Science Center,
you're describing the exact equipment that we would use to describe it.
Yeah, exactly. So all the planets are these little marbles that are sort of stuck in this funnel shape. But in space, there's no friction, there's no loss of energy, so they don't slowly fall towards the center into the sun. They just stay on those tracks around the funnel.
That's right.
Well, in 2021, something huge happened. And I remember watching the news. It kind of felt like when I was younger, where there was like a new Madonna video, or, there was a new Back to the Future movie. I'm aging myself. But when the James Webb Space Telescope was launched, there was so much excitement. And it wasn't just like, I guess, in the science world, but we all seemed kind of glued to the news for something that was actually could benefit us as on the planet. Can anyone explain the details of the launch of the James Webb Space Telescope?
Sure, I guess I have to. That's right. I'm the acting scientist for Webb.
Hanging around your neck.
That's right. I always have the mirror on me.
That is so cool.
So yeah, this is a mission that is led by NASA, but with collaboration from the European Space Agency, and very exciting for us, the Canadian Space Agency. It's the largest space astronomy mission that Canada has ever been involved in, and it's been in preparation for over 2 decades now. Sort of, we call it the successor to Hubble. But a lot of differences. It's a lot bigger. It's the biggest telescope we've ever sent into space. And it looks at a different kind of light. It looks at infrared light, which is invisible to us, but super useful in astronomy to study all kinds of things, from the birth of stars to distant galaxies to exoplanets. And so finally, December 25th, 2021, it launched from Kourou in French Guiana. And lots of us were supposed to be deployed all over the world. The team, I was supposed to be in Baltimore with the operations center, but we had to shut down because of COVID. So we were all watching home, but we had the comms loop on, and we were all 7 in the morning looking at the television and looking at this big Ariane 5 rocket launch it into space. And I think we were all crying. And
why were you crying? Like, because I just thought it was. So, I was just like a regular person just watching it, and I was really emotional. But for you, it must have felt like, I mean, you're tearing up right now just talking about it.
Yeah. I'm just thinking of that moment. I can't even imagine what it was like for some people who have spent their whole career working on this telescope. I don't have children yet, but I can imagine maybe it's like sending your kids off to college for the first time, and you're not too sure if they're ready for the experience, if you've equipped them appropriately. But it was just a lot of years of work being poured into this one moment, and you're confident that it'll go well, but there's always that one little worry that, this is a giant rocket engine that could blow up and destroy all this work. But luckily, it didn't happen. The launch went wonderfully, and the mission is still going wonderfully now.
I want to get everyone's input on this. What was it like for you to watch that?
Much the same as Nathalie, just terrified. I think, how many different points of failure were there? Like
300, over 300.
There were 300 different points of failure, and some of them were super finicky. Like this mirror had to sort of unfurl robotically in this incredibly complicated way. So I just tried to distract myself, because if I thought about it, I would just convince myself there's no way that this is going to work. And so I sort of stopped, turned off the media and TV, and just sort of waited for the whole unraveling process to complete. And I'm still sort of astonished that it worked. I mean, so many satellites do blow up on the launch pad, and you see some colleague who's spent like 20 years on this, and for some reason it has nothing to do with them, like their whole career is now just a fireball. So I was just terrified, and just basically wake me up when it was over.
When it's done. When you say 300 points of failure, like 300 ways that it could go wrong.
Right. There was this whole complicated stage where this thing that was sort of wrapped up and compressed and packed into this sort of way in which it would fit into the rocket had to sort of unfurl like one of those pop-up books into a telescope. And it was this incredibly complicated process. And if any one of those steps failed, then the next steps could not proceed, and it would just be a worthless piece of junk.
Wow. Matthew?
Well, I mean, you strapped 1,000 dreams to a high explosive and crossed your fingers. I mean, I think they've nicely described, just the human effort that went into making this happen. But it's incredible what that human effort can do. I mean, This is one of the most amazing technological achievements in humanity's history, and I don't think that's an understatement. If you've had a chance, like, watch the video of all the steps that are supposed to happen to go from being inside the rocket to being, past the orbit of the moon, looking out into space. It's just phenomenal, and beautiful images and beautiful science, and already there are controversies, and it's a really exciting endeavor. I mean, it's just incredible what people can do, what humanity can do.
You mentioned the images. When those first images came out, you thought what?
Beautiful.
Beautiful.
Yeah, it's just beautiful. It's like art, right? Yeah.
And what about you, Walter?
Yeah. So, of course, at the Science Center, we all scrambled around. It's like, oh, it's launching, right? And everyone's getting in touch with everybody else, saying, let's watch, right? Because it is exciting. It's amazing, and it's going through all of Hubble's greatest hits, right? It's been looking even deeper into what we thought we knew, and now, we know a little better now. We know a little more. So it's an exciting unraveling of some of the mysteries that we still don't have answers yet.
I want to talk more about Uranus. I'm going to show you an image right now. This is an image of Uranus taken by Webb's near-infrared camera. Here we can see the solid rings around an aquamarine blue planet. Uranus is an ice giant, the third largest in diameter, 27 known moons, 13 known rings, rotates on its side. Theoretically, it could rain diamonds? Say what now, Natalie?
Yeah, the atmospheres of the gas and ice giants are really weird because they're ice, and when we say ice, we don't mean like water ice. It's another kind of weird ice and gas, but because they're so massive, layers of them are compressed to like hypercritical stages where they're kind of this in-between phase where they're not quite fluid, they're not really solid, and it's not something, that kind of material that you have sort of all around you. And you end up having really weird things like diamond rains.
Going back to that image, what makes this image of Uranus so unique?
So what I really love about this picture of Uranus, and also there was a picture of Neptune that was released a little bit beforehand, I often like to think of these two planets as the forgotten siblings of the solar system because they've never gotten their dedicated mission or probe. Even Pluto, who is not a planet, as we know, had New Horizons, but all Uranus and Neptune have had are flybys by the Voyager probes. And that happened in the 80s. So since then, we've had not that much information and not that many images of these planets. And now with Webb, we have this new tool that allows us to see a lot of changes have occurred since those flybys that we don't necessarily understand.
I don't know if you want me to bring back that image, but I wanted to get everybody else's reaction on that image of Uranus. Matthew, looking at that, you think what?
Those books that my son was really into, that he first saw in the library and got into planets, that were images taken in the 80s, are so much worse than this. It's just so beautiful. It's incredible how detailed and wonderful. I mean, you can see all the detail in the rings, and
it doesn't look real, like when I look at it, right?
Totally, right? Yeah, it looks like
a painting.
Yeah,
it looks like a painting.
It looks like art. Yeah.
Oh, Bryan, what do you think?
So I feel cheated that we don't have rings. I mean, there are 4 planets that we know of that have rings, and each of them are different, and they're all quite spectacular and beautiful. And we don't have them. And I've seen space art and science fiction where what it looks like to be on the surface of a planet when there's like rings arcing over the sky, and I'm thinking like, none of us could do anything but look up all the time if there were like rings arching over the whole expanse. So one day I want to be on a planet with rings around it.
I wonder if there's someone we can talk to about that. Make it right.
You could blow up the moon, but that would make less rings, but that would create other problems.
Wasn't that one of the Goldilocks conditions? Remember where I keep my stuff.
So true. What do you think, Walter, when you look at that image?
So it's gorgeous. It's absolutely beautiful. And there was something that you said that kind of triggered my imagination. So that what's the temperature on the surface? Like, we're calling it an ice giant, right? But isn't it a few thousand degrees Celsius, right? Because it's
If you go deep enough
inside.
inside,
Okay,
yeah,
okay.
that's right, yeah. But no, on the surface, it's I believe the coldest of the planets. Very windy. You wouldn't want to live there. You wouldn't want to have your
forget it,
stuff
forget it.
there.
Never mind that.
Certainly, no.
Just extraordinary.
Well, on tomorrow's show, we're going to be talking about the galaxy. So I wanted to kind of bridge our discussion with our discussion for tomorrow. How does our solar system move through the galaxy? Nathalie?
Yeah, so a lot of people think that we are around, like, they're comfortable with the idea that these planets are going around the sun, but they imagine the sun being still. But no, it's careening 225 kilometers per second around the center of our Milky Way. And it takes a very long time, about 250 million years, to go all the way around. And at the heart of the galaxy, we have this supermassive black hole, this monster that's not any danger to us, luckily, but...
I mean, you say black hole, I'm like,
I know. But so you have the sun and you have the planets moving around it, but really they're all moving around the center of this galaxy. And I always like to tell kids, the last time we were exactly in this spot in the Milky Way, there were dinosaurs on the Earth. And not the recent dinosaurs, like some of the first dinosaurs.
When you say that, they say what? Like,
They can't, it blows their minds, I think. If you combine dinosaurs and astronomy, forget it. The kids are really enthralled.
Well, the other thing I love is that not only is the sun and the solar system going around the galaxy in a circle, but it's also, as it does so, it's bobbing up and down like a cork on the water. So it has this sort of oscillating pattern as it goes through. And so some of the things that we don't understand about the history of the Earth, things like ice ages and extinctions, could actually be related to sort of different conditions and gravitational interactions that we experience as our whole solar system very slowly bobs up and down. So the orbit is actually very complex, and every other star in the galaxy is doing its own thing, its own circle and its own bobbing as well. So it's this incredible, complicated ballet.
it makes up the fact that we don't have rings.
Yeah, I love our galaxy. It's just such a beautiful, amazing place.
Well, we're going to talk more about the galaxy on tomorrow's show. But thank you so much for this. It's been really illuminating. I wish I was I don't know if you teach classes, want to write books. I want to read all the things and listen to all the lectures. Thank you so much for helping us understand this. Appreciate your time.
Thank you.
Thank you.
Our guests all this week are...
Bryan Gaensler, Director of the Dunlap Institute for Astronomy and Astrophysics, and Canada Research Chair and Professor at the University of Toronto. Astrophysicist Nathalie Ouellette, who is Deputy Director of the University of Montreal's Trottier Institute for Research on Exoplanets and Outreach Scientist for the James Webb Space Telescope in Canada. Walter Stoddard, researcher programmer and longtime science communicator at the Ontario Science Centre. And Matthew Johnson, associate professor of physics and astronomy at York University and research associate faculty at the Perimeter Institute for Theoretical Physics.
The Agenda in the Summer with Nam Kiwanuka is made possible through generous philanthropic contributions from viewers like you. Thank you for supporting TVO's journalism.